Let's take a look at setting up static routes for IPv4. We took a look at creating our IPv6 static routes. So what's the difference between IPv6 and IPv4 static routes? And the answer is the format of the address. That's it. Effectively, the same exact thing happens. If we look at the infrastructure that we have here, we have router 2 that's connected to the network, whether it's the network, the internet, an extranet, something. This is in a data center. This is in the corporate location. So when R2 comes up, we could choose to just do a static route that says, hey, I know that I have the 172.16.3 network out here. So R2, if you see the 172.16.3 network, send it either out this interface or to this next hop address. And I could do that for each of the remote networks that I have, do a static route out to each remote network if I wanted to. And that would work perfectly fine. Again, maybe the dynamic routing protocols could be more efficient, especially in an environment where you're adding or deleting networks. But certainly a static would work for us here. If we look beyond this, if we look back out at what we call this stub network out here, that stub network doesn't necessarily need to have all the paths to all the other networks. It can just have that default route like we did with IPv6. In the IPv4 world, in the IPv6 world, we said, oh, in our stub network, let's just default it back to the corporate data center. And again, in V4, we'll do the exact same thing. We could tell R1 out here that, hey, R1, if you see any network you don't recognize, send it back to corporate, send it back to the data center, send it back to the hub in the center of our universe, if you will. So what happens here is we create one of those static default routes and we send it back, and then any traffic that we don't recognize will go back to the data center, to the center of our network. We could also think about, well, what happens if we have multiple networks out there? So as an example of creating maybe a summary static route, again, something just to think about. If I were to say that I had a router out here in a branch office, this router in this branch office, this is a fairly large branch office. So what I have out here is I have the 192.168.4 network, and I have the 192.168.5 network. It looks like 40, but it's a 4, 5.0. And I have the 192.168.6 network, and I have the 192.168.7 network. So ultimately what I have out here is the 4, 5, 6, and 7. And now I have a point-to-point connection back to my corporate data center back here. And I need to create, I could use dynamic, but we're talking about statics here. So I'm going to create a static route that goes out here. Am I going to have to create 4 static routes? Those 4 static routes to point to this next hop address over here. Again, it could be out my serial 0/0 interface, or it could be the next hop IP address out here, whatever this is, 68.100.1. Again, I made this up. We don't have any reason to know what that address is, but that would be the next hop address. So do I create 4 static routes here that all point to the 4, 5, and 6 network out there? The answer is I don't need to. I can actually do what we call summarization. I can summarize these into one because I did my design correctly. So let me jump out of here for just a second and talk about a block size of 4. What I'm going to tell you is I could actually take a block size of 4 and implement it on my 3rd octet here, 4, 5, 6, and 7, and I can summarize all 4 networks into one statement. So again, I probably should have put my mask out here, /24, /24, /24, /24. So I have 4 full class C networks. Well, how many networks is that? How many hosts can I support on a /24? Well, there's 256 addresses, but I can support 254 hosts, but there's 256 addresses. So I got 256, I got 512. So out here I have 1,024 addresses out here. Again, I can't use them all. Some are network ID, some are broadcast ID, but they all exist out here in this branch office. If I were to say I have 192.168.4.0/22, what does that mean? What does this /22 do for me? What's it different rather than /24? Well, it means I have 2 more zeros in my subnet mask. So /22, if I do it in dotted decimal, is 255.255.252.0. That's actually 22 ones. There's 8 ones here, there's 8 ones here, and there's 6 more here. 8 and 8 is 16, and 6 is 22, so that's my /22. Now we know from earlier that we have this really cool formula, 256 minus funky is block size. So what block size am I looking at? Well, again, we could do the math. 256 minus 252. Don't think we had to write this 252. Don't think we had to write this down. 6 minus 2 is a block size of 4. It's a block size of 4, though, in the third octet. So my block size of 4 belongs here. Okay, so we're getting there, slowly but surely. We know we're block size 4. We know we're in the third octet. And we're trying to figure out what my valid range of addresses is. So what is my valid range of addresses? Again, we've done this in the past, network first / broadcast. So if I got a block size of 4, it's 0, 4, 8, 12, ... Don't need any more because 4 is right here. So 4 is actually the network ID. What's the broadcast ID for the 4 network? 1 less than 8, it's 7.255. So what's my valid range of addresses? 4.1 through 7.254. Whoops. Whoops. Whoops again. There was 2 whoops in a row. 254. 4.1 through 7.254. 4.1 through 7.254. So with this one entry, I can include all those addresses. /22, 22 ones, that's 10 zeros, 2 to the 10th, 1024. That's exactly how many addresses I have out there. One entry gets me those 4. That's called summarization or route summarization. The dynamic routing protocols will do this for you. If you're going to create static routes, you may want to do it yourself. I have one more thing I need to point out to you before we go. And that was because of a proper design, because I chose to do 4, 5, 6, and 7 out here. If you had gone with some of the old schools of thought and decided that you were just going to do whatever, you were going to look around and pick whatever random numbers that you wanted. So out here, instead of doing 4, 5, 6, and 7, you decided in your infinite wisdom that you were going to do 4, that works great, but you wanted to have 32.0 here, and then you wanted to have 35.0 here, and you wanted to have 108.0 here. You cannot summarize these. They have to be contiguous. They have to be 4, 5, 6, and 7, or 8, 9, 10, and 11. They can't even be 6, 7, 8, and 9, because my block size 4 doesn't cover these 4. My block sizes have to start on 0, 4, 8. So if you're going to have 4 networks in your branch office, you must start on a block of 4. I mean, I could still summarize, but I'd have to summarize on 6 and 7 and 8, 9. I have to use a block size 2 to do it. You're much better off making the decisions based off what you have out there. Don't do random. Do a well-designed, cohesive, thought-involved network diagram.